the sequence of diagrams I need. We have to find out all these things. So let me explain the problem. It's a diagram based question, nothing to do, anybody can do this one, provided if you have all the set of diagrams. Okay, there's the initially as it is. So first it will come and collide. There's a collision occurs. After collision, shall I make it 2 kg, 1 kg? So this will become 3 kg. Or let me show that cell here. Initially the string was taut, no? And just after impact, this will acquire a velocity, say v1. What should happen to string now? Very next moment. String will become loose because the b what happen? Starts moving up and the string will become loose. Because as the string become loose, what happen? The A will have free fall motion and B will be vertically projected. The string will be very next moment, the string will become slack and it will start ascending like this. Earlier it was, now sling, you better write slack. Then what is the type of motion? A will have free fall motion. And what about the B? B will be vertically projected and along this motion will occur. It will have free fall. And this will be vertically projected. And it will come to instantaneous rest for a while. Because of gravity, this will have free fall motion. So here, what is the state of the block? The block A will have velocity, call VA1. And what is the state of block B? It will be at instantaneous rest. I'll write IR, is understood instantaneous rest here. Along with the particle also, shall see, I'll show it. This is at t equal to 0. This is just greater than 0. This is at certain time. Let me call t equal to t1. Can we write anything? So what height the block A descends is the same height the block B will ascend. You have to answer this particular thing. Yes, it will be a H1. This will be H1. So what is H1? How to calculate? Yes, we can write H1 equal to half GT1 square. And we also can calculate this time T1. It was projected with a velocity V1. How to calculate velocity V1? Applying impulse momentum. I'll come to all that later on. Very next moment, what will happen to this? What actually goes on, first we'll analyze here. Very next moment, you see that the string will be slack here. The ends of the string, what now they have different velocity. No, you can see that this block A will try to move down, and the block B will also try. Block A will, because the velocity will move down. And what about block B? It cannot ascend further up because of the weight. What it will try to move down. So what happened to string will become taut. Suddenly the string will become taut. The same position, the string will be a jerk is produced and it will become taut. It was slack. Now it will become out. So then how the impulse should act? The impulse is set up and that impulse will act in this direction. So how the velocity of this will be? The velocity of this will be in this direction, v dash, and the velocity of this will be v1, we took it, no? So we'll write it v2. Very next moment, this will be the sequence. There's a particle. An impulse is set up, there's a condition. Okay, after this, next condition, what will happen? How long this, and suddenly what happened as it ascends? So impulse is acted and we know velocity v2. Because of these velocities, no, you take out that impulse now. Impulse is set up, it has a given velocity v2. Now because of these velocities, now what will happen to block B and A? It will start ascending, and you look at that, the resultant weight here, how much it will be? 3 mg. Here, how much it will be? Only 2 mg. Look at that one. Mass of A and B are 2 kg. 2 kg. This is 2 kg. This is 1 kg. What do you expect now? There'll be retardation in this direction. Due to retardation, so what happened to speed of the blocks A and B, and that this particle C will undergo retardation, and for a while they will come to instantaneous rest. So call this as, this height as, say, V2 we have taken, let it be H2. After this, what happened? Again, anything will happen. They'll start moving down because of weight 3 mg and this is 2 mg. So after this, the A will start rising up, B will start falling down. Again, it's a laws of motion problem. This is what overall the sequence. So what are all questions now? All of you can understand that what actually going on. Now you write equations. Say without this background, no, I don't think, I think you are in big trouble. You are in very big trouble. So let's see that. Calculate the time after which the block B starts moving downward. Maximum height reached by block B. So maximum height reached by block B means what I should do? H1 plus H2. Calculate the time after which the block B starts moving downward. Means what I should do here. So look at from here. It was at rest, collides, acquire velocity v1. It is continuously ascending up only, no? Nowhere it has descended. After this, it starts moving down. So he's asking this particular time interval. So from year to year, these are the times. Times, this is T1. Then impulse is set up. This is T2. So that T1 plus T2, H1 plus H2 is asking. Then loss in mechanical energy, we'll see how much it will come. It was at instantaneous, here it was at instantaneous rest, impulse will act and it will acquire velocity V2 and it will ascend finish over. Then impulse will happen. See, once it will acquire V2, then it's again, it's a laws of motion problem. Again, the tension will take the normal values. The JT, what's happened here, the suddenly tension will increase, becomes maximum, then decreases. There's a sequence that occurs here. When impulse is set up, the tension will suddenly increase, becomes maximum, then decreases. JT will not act for large duration of time. For a fraction of time, the JT will act. That's why we can write JT equal to, this is 2m m. So JT equal to 2m plus m v into V2. Okay, this is about the background is what I given. Okay, let's write all the equations. I think problem is over. So you're supposed to manage this much here. Looking at the diagrams, let's write the equation. First, how to calculate this V1. It will collide, no, starting from first diagram. The shell C, it's having a mass M, 1 kg. The shell C is having a mass 1 kg. Let's write impulse momentum equation. I'll first looking at this 1 into mass of the MC. So let me take this is U. MCU is equal to MB plus MC into V1. So this is 1 kg. U is how much? 9 meter. 2 plus 1 into V. So V1 equal to 3 meter per second. Okay, after getting this, I got V1. Now, can we calculate VA1? VA1 equal to GT1. We don't know this time T1. How to calculate time T1? Time T1, it is measured from here. So it was a given velocity V1, gravity will act. Due to that, it's undergo retard. It's like a vertically projected. So can we calculate T1? 0 equal to V1 minus GT1. Okay, T1 equal to V1 by G. So V1 we know, I'll get the T1. So T1 equal to V1 by G. So this will be 3 by 10, 0.3 seconds. I'll write everything here only. It'll be much easy for you. Then after getting T1, can we calculate VA1? So what should be the VA1? VA1, it will free fall, no? GT1, 10 into 0.3 meter per second. So this is VA1. Can we calculate H1? Better to use simplest thing. So 10 by 2, T1 square, 0.3 whole square. So we'll get H1. So after getting H1, then let's come for this. Immediately here, look at this. So we have to calculate the V2, no? How to calculate that particular V2. So let's go for this impulse GT, no? So this will be on the block A. For block A, MA VA1 minus JT is equal to MA V2. Then on the block B and C combined, because it was instant range, then suddenly the string has become taut. So JT is equal to MA plus MC into V2. Adding up these two, we'll get expression for V2. After getting V2, then we have to calculate the time T2. For that, we need retardation. What is the retardation? Retardation will be 3mg minus 2mg by 3m plus 2m. I think this should be equal to g by 5, 2 meter per second square. So can we calculate the time taken? So this should be 0 equal to V2 minus AT2. So from this, we'll get the T2. What is the total time taken? That one, T1 plus T2. Then can we calculate H2? Again, the same formula, 0 minus V2 square 2 minus A H2. So H1, H2, we'll get the T1 plus T2. There are the things. What about loss in mechanical energy? Due to collision, here some energy is lost. And again, the string has become slack. From slack, again, it has become taut. You see that this was the energy, no? V1. So again, there's a loss in, again, you see that here calculate the kinetic energy. So there's a, whenever the string from loop becomes taut, from slack it becomes taut, or from taut it becomes slack, there'll be loss of energy. So here, due to collision, there's a loss of energy. String has become slack. Okay, there's nothing to do here. So no loss in energy in the second diagram. Here it is having, there's a loss in kinetic energy, loss in mechanical energy due to collision. From taut, it has become slack. Any loss in kinetic energy? Nothing, no. A was at rest, it continued to be at rest, inertia of rest. And B, what happened? It was having velocity V1, it will be velocity V1. So no loss in energy here. Then it will ascend. It will ascend. So at this particular point, what is a like a B instantaneous rest? And what about A? A is having kinetic energy. Suddenly string has become taut. So again, there'll be loss in energy here. So now you calculate energy of ma va1 square. Here, of ma v2 square of 3m v2 square. Check this energy now will be less compared to this. Is it okay now? So the loss in kinetic energy here occurs, and also in these two events it will occur. So what is the total loss in mechanical energy? E loss. I'll write this one. This should be equal to mc u square by 2 minus mb plus mc by 2 v1 square. This is due to what? Due to collision. Again, next again, the string has become suddenly from slack taut. So what was the energy here? ma va1 square by 2 minus ma v2 square by 2 plus mb plus mc So this what you should interpret, how you should interpret here. Due to change in tension, there's a loss in mechanical energy. Do calculation later on. Now from taut string becomes slack, no loss in energy. It's very clear. So I'll write it here, nearby diagram. Loss in kinetic energy. Here also loss in kinetic energy. And here what will happen to that loss in mechanical energy? Will be converted into heat, sound, or deformation of the block B and the particle C here. What about your loss in kinetic energy? Who will take? They'll be taken by the string. Able to interpret energy aspect here. The loss in energy will be in the form of deformation of the block or sound or heat. What about here? It will be taken by the string. It will be consumed by the string. Heat generated in the string here.